Okay, this is the 8.3 pre-cal homework assignment, and it's on the Pythagorean identities. I just want to go through it real quick. Remember, since this is a video, you can pause it if you get stuck. So this one says to simplify, so we don't have to set it equal to anything. What we do know in this first problem is that they both have a cosine, so we can reverse distribute, also known as factoring, and write it like that. And then I see a square, so I'm going to go up here and I notice that 1 plus tangent squared x is equivalent to secant squared x. So I'm going to change that to secant squared x, or secant squared theta since I have a theta. And then I know that secant squared is 1 over cosine squared. So one of these cosines will cancel with one of those. So I have 1 over cosine theta, which is equal to secant theta. Okay, for the next one, I see a square right away, so I'm naturally going to go look up here because I've been doing this for a while, but like I see 1 plus cotangent squared. Anytime I see like 1 and something squared, I immediately look up to my Pythagorean identities. So 1 plus cotangent squared can be written as cosecant squared theta, which is like this one right here had an extra step. We had to factor first. This one's already been factored for us. So then we have sine theta times 1 over sine squared theta. Again, same thing. This is like really over 1, so that will cancel with one of those. So I have 1 over sine theta, which equals cosecant theta. For this one, again, I see a square and I see a 1 with it, 1 minus cosine squared. So if we go up to this, or if we use our pink sheet, we can see that 1 minus cosine squared x, another way to write that is sine squared x. So I have cosecant x, and then this whole thing becomes sine squared x, changed to sines and cosines, so this is 1 over the sine of x times sine squared x. And now I have more sine squareds in the numerator, so this one cancels with this one, and I just am going to end up with sine of x. Okay, moving right along. So if we look at this next one, it says cosecant squared x minus sine of x times cosecant x. So when I see this one right here, there's lots of things you can do. I see a cosecant squared x, so if you wanted to, you could change that to 1 over sine squared x. I also see a sine x and cosecant x, so we can do some work there too. I know I'm getting to cotangent squared x, and since I'm going to cotangent squared x, what I really need to know is cosecant squared x minus 1 will change to cotangent squared x. So if somehow, some way, I can get this side to say cosecant squared x minus 1, well, I already have cosecant squared x. So that's why I'm only going to work with this guy instead of this guy, because I know I'm looking to where I'm trying to get to. So cosecant squared x minus sine of x times 1 over sine of x equals cotangent squared x. So then what's going to happen here is this is going to cancel, and I'm just going to have cosecant squared x minus 1, which again, I was kind of hoping to get that because when I looked on this sheet, I saw that cotangent squared x, which is what I have here, is cosecant squared x minus 1. Since I already had the cosecant squared x, I didn't want to mess with it because I knew that if I had that and I could get this other piece equal to 1, then I would have the identity. So that's what I'm going to do now. I'm just going to change this to cotangent squared x equals cotangent squared x. Okay, moving on to this one right here. So I have a sine x and a sine x, and then I have a cosine squared x here. So there's lots of things that you can do. You're trying to get to sine cubed. And in this one, I see 2 sines. So if I factor out a sine, then I would have 1 minus cosine squared x equals sine cubed x. So then I take a look at my identity sheet, And another way to write 1 minus cosine squared x is sine squared x. So here's the one in front, and then I'm changing this to sine squared x equals sine cubed x. So then I have 3 of them. So sine cubed x equals sine cubed x. Moving on to this one right here, I have 1 over the cosine of x, which I'm not even sure that I want to do that. Let me take a look. I'm going to back up just a minute because I want to take a look at where I'm trying to get to. So I'm trying to get it to be cosine x, okay? And there's no squares yet. So maybe I will do that. I'm just going to mess with it for a second. 1 minus cosine x, 1 over cosine x. Why not put everything in terms of sines and cosines? So I'm just switching things around right now, and I see that I have 1 over cosine x. So this would be 1 over cosine x minus sine squared x over cosine x. Oh, this only has 1 term over here, and this has 2, so I need to get them to have common denominators so I can combine them. Oh, look, they already have common denominators. So I can write the numerator over that common denominator. Okay, so I have a cosine x, and there's a cosine x, but this is in the denominator, so if there was only a way I could change this, so I go, look, there's a 1 paired with a Pythagorean, a squared term, and so right here, 1 minus sine squared x can be written as cosine squared x. And then this square cancels with this, so I get cosine x equals cosine x. And then for this one, this is what I'm wanting you guys to get familiar with, is that like there is a tangent x plus a cotangent x. So this is 2 terms. When we don't have any addition or subtraction, that makes that 1 term. So in order to get it from 2 terms to 1 term, we have to switch things around and probably get common denominators. So I'm going to do sine x over cosine x plus cosine x over sine x equals secant x cosecant x. Okay? Now I still only have 2 terms, but we already learned in a previous lesson that to get common denominators, we just need to multiply each denominator by what the other one has. So those are both sine x, and these are both cosine x. So in the numerator with my common denominator of sine x cosine x, I have sine x times sine x, so that's sine squared x, plus cosine x times cosine x. Ooh, I see a Pythagorean identity. I wonder what this could be. This, sine squared x plus cosine squared x, you can even see it on the top of your paper, that just equals 1. So I have 1 over the sine of x times cosine x. But where am I trying to go? To secant x cosecant x, right? So if I'm trying to do that, this could be 1 over the sine of x. And then couldn't this also be 1 over the cosine of x? Because 1 times 1 is still 1, and sine x times cosine x is that. So then now when you're multiplying, order doesn't matter. So 1 over the sine of x is cosecant x. Whoops. And 1 over the cosine of x is secant x. So then in proper form, I get these to be equal. Okay? I'm running out of time here, so I'm going to go ahead and just show you guys the work for the backside and talk through it. So when you flip it over, this is the math that you have. So cosine and secant are reciprocals. So this doesn't even really belong in this chapter. This is a review from the previous chapter. So you would just do that. And then same thing with cotangent and tangent. You're just going to reciprocal them. Now here, sine and cosine are not reciprocals of each other. You are given sine, so you should go to the trig identity that has sine in it. So sine squared theta plus cosine squared theta equals 1. Well, they tell us sine of theta is negative 1/5, so all of sine theta becomes negative 1/5, and then you're squaring it. And then you don't know cosine squared, and that equals 1. Negative 1/5 times negative 1/5 is positive 1 over 25. You subtract it, then you square 1 minus 1 over 25. This is going to be 25 over 25. So then you get the square root of 24 over 25. Don't forget the plus or minus.